Assalamualaikum, we are from Group 2 of BMMM4623. We'll present about Lab 1 Kinematic Viscosity. First of all, my name is Nurhafiza binti AWANG KHALID. We'll explain about the objective of this lab. The objective of lab kinematic viscosity is to measure the resistance of a fluid to flow under specific conditions and also understanding and comparing the viscosities of different fluids to select the most suitable one of specific application. For the methodology of work process, I will pass to the next presenter. Thank you.
Assalamualaikum, my name is MOHAMAD HAMIZAN bin Muhammad RIDZWAN, and today I want to present for my part, which is the work process for kinematic viscosity. Kinematic viscosity, there's three main points, which is the kinematic viscosity preparation, control parameter, and lastly the kinematic viscosity test. For the kinematic viscosity preparation, we will use the Kittiwake viscometer to find the viscosity value for each oil sample. And second, we will use the sample oil that we get from the engine oil. And for the third point which is the ASTM D2270 standard, this is a table to find the grade of lubricant oil. For the second main point, which is the control parameter, we will use a different type of engine oil, which is the sample C and D, and also we can control the parameter for the kinematic viscosity value that we obtain at 40 degree and 100 degrees Celsius. And lastly, why we use the kinematic viscosity test, because to understand the kinematic viscosity measurement method. Second, which is the determine the viscosity index each the lubricant sample, and lastly to grade of the lubricant oil based on the viscosity. Thank you.
Okay, hi, Assalamualaikum. My name is Muhammad or AIMAN bin Muhammad JAILANI, and my metric number is B09201033. So I will continue this presentation for my part, which is result and discussion. So based on the experiment we have been performed, to determine each oil sample's potential SAE, or the Society of Automotive Engineers short form, viscosity grade, kinematic viscosity at 100 Celsius of the sample was compared to the SAE J300 viscosity grade for the engine. So based on the data that we get from the experiment that we have been performed on the sample C and D, the average value of kinematic viscosity at 100 Celsius are 8.5 CST or centistoke, and 8.1 CST, which are graded at SAE 20. So why SAE 20? An SAE 20 oil grades viscosity range measured at 100 Celsius was from 5.6 CST to 9.3 CST, which was a much broader range than the SAE 30, 40, 50, and 60 grades. So next, as we can see in the poster, on the right side of SAE grade system, there are graphs that shows a decreased trend of sample C to D in all parameters. So as we can see, we notice that the sample C has a higher viscosity index and kinematic viscosity for both 40 degrees Celsius and 100 degrees Celsius. This shows that sample C has a better quality and then the sample D. We also can see that there is a linear decrease line in the graph that shows viscosity index of sample C and D. So for sample C, the viscosity index is 99.39, and the sample D viscosity index is the 99.13. And that's all from me. Thank you.
Assalamualaikum and selamat sejahtera. My name is SYAFIQ, and today I'm gonna present our method that we use in the laboratory experiment to gather the viscosity index from the laboratory experiment that we have conducted. Okay, viscosity index is an arbitrary or unitless measure of an absolute change in viscosity relative to the temperature change. It is mostly used to characterize the viscosity temperature behavior of lubricating oils. The lower the viscosity index, the more the viscosity is affected by changes in temperature. The higher the viscosity index, the more stable the viscosity remains over some temperature change. Okay. From the experiment that we conducted, we used the viscosity formula as stated in our assignment post. That's all from me. Thank you.
Hello, my name is BRISSCO JAIMISSEUS and my metric number is B0920102447. So, in this experiment, we can sum up that the kinematic viscosity measurement offer a vital information on oil resistance to flow, lubricating qualities, viscosity index, and oil classes based on viscosity. The viscosity index measures oil stability across various operating situations by measuring viscosity variation with temperature. The factor provides insight into lubricant performance, optimizing appropriateness for various applications. In other words, we can say that in kinematic viscosity experiment, the measurement provides a crucial information about an oil resistant to flow under specific condition, aiding in the assessment of its lubricating properties, determination of viscosity index, and oil grades based on viscosity. The viscosity index quantifies how viscosity changes with temperature, indicating the oil stability across a range of operating conditions. This parameter offers a valuable insight into the lubricant performance characteristic, helping optimize its sustainability for diverse applications. That's all from us. Thank you.